Good morning, students. Today we are going to learn 10th standard quick revision mathematics chapter number 7. In this quick revision, we'll discuss chapter number 7 coordinate geometry. Now, the important points in coordinate geometry are xy system. In another way, xy coordinate system. In XY coordinate system, we'll discuss about origin, positive, negative axis, quadrant and their respective sign. Abscissa, ordinate. Then we'll discuss about the coordinate of point on the x-axis and y-axis. If any point lies on x-axis or y-axis, what must be the coordinates? Then we'll discuss about the distance formula. Then distance from origin, the distance of any point from origin, the distance of any point from x-axis, y-axis, there is a direct formula, we'll discuss about that. Then we'll go for the section formula. Now in section formula, there is an internal division, midpoint formula and then centroid formula. Vertices of a triangle. Find the third vertex. Like this questions are there. We'll discuss about the formula regarding when two vertices are given or midpoints are given, how to find the third vertex or missing vertex. Then fourth vertex when the three vertex of a parallelogram are given. And then at last we'll discuss the relation between the coordinates of parallelogram, rhombus, rectangle and square. There is a common relation between the coordinates of these vertices, and on the basis of this formula there are the MCQs. So we'll discuss the most likely questions regarding coordinate geometry. So let's start with the XY system. Now what is this XY coordinate system? So from 5th, 6th standard we are learning the number line. When the two number line intersect each other at right angles. When two number line intersect each other at right angles, passing through the origin, that is O. Then the plane is divided into four parts. And when the plane is divided into four parts, the each part in anti-clockwise direction is named as first quadrant, second quadrant, third quadrant and fourth quadrant in anti-clockwise direction. The horizontal number line is called as x-axis and the vertical number line is called as y-axis. As you know, the right hand side of the number line is positive and this one is also positive, and left hand side of the number line is negative. In this way, the system form which divide the plane into four parts is called XY coordinate system. In this first quadrant, the coordinate of the first quadrant are denoted by both the positive sign. X and Y coordinate of any point which lies in the first quadrant, as it is included between the positive direction of X and Y axis, the sign of the point are plus plus. The sign of the coordinate of the point in second quadrant are minus plus. So always the ordered pair is X and then Y. Then third quadrant negative and fourth quadrant plus minus. These are the respective sign of the point which lies in a particular quadrant. Now if P is any point whose coordinate are 2 and 3, then the first coordinate is called as a x coordinate and the second one as a y, where the x coordinate is also called as abscissa. The x coordinate is also called as a abscissa, while the y coordinate is also called as a ordinate. Is also called as a ordinate. So we discuss abscissa, ordinate. Let's move for the coordinate of point on x and y axis. Suppose any point lies on x axis, you can see the x coordinate is 2 while the y coordinate is at origin. That is, any point on the x axis, its y coordinate is 0 and x coordinate, let's assume as a small a. Any point on y axis, so it's any point on y axis, what will happen? Suppose point is here, so here y coordinate is 3, but what about the x coordinate? The x coordinate becomes 0, and these are the points for any point which lies on x axis. The coordinates are a comma 0, and any point which lies on y axis, the coordinates are 0 comma b. So these are the coordinates of point on x and y axis. Now let's discuss about the distance of the point from origin and then from the x axis, from the y axis. First we'll discuss about distance of any point from the x axis. So it's really very simple to remember that. Suppose this is a xy coordinate plane. Here it is a P point which is in the second quadrant, and as it is in the second quadrant, the coordinates x coordinate must be minus while y coordinate must be plus. Now if we draw perpendicular from this point and this point to the x dash and y axis, it is the origin. Now distance of this point from x axis, distance of this point from x axis is nothing but the y coordinate, and there is a shortcut formula for that. Distance of any point, suppose this is a comma b, so we write down as x comma y, from, if it is from x axis, then it is a mod of y coordinate of the particular point whose distance we have to find. If we are looking for the distance of point free P from x axis, then its distance is mod of 5. It is in second quadrant. If it is in the third quadrant, then minus 5 will be there. Distance can never be negative. That's why this mod value is used. Similarly, y-axis, the distance of point from y-axis is nothing but the x-coordinate. Here the x-coordinate is minus 3 and the distance cannot be negative. So distance is the mod of x-coordinate. Here x-coordinate is minus 3. Therefore, the distance of the point P from x-axis is y-coordinate, that is 5. The distance of point P from y-axis, that is the x-coordinate, but it should be always in a mod value, that is positive, so 3 units. So this is a very, very important concept, useful for solving MCQs. Now let's discuss about the section formulas. Now what is the section formula? So section formula is the division of any particular point either internally, externally. So in 10th standard there is only internal division. In later on in 11th we'll discuss about the external division. Now what is the internal division? Suppose this is a segment AB and we have given the coordinates of A as x1, y1 and B as x2, y2. In xy coordinate system, by forming a right angle triangle, we can derive the distance, but we are here directly using the formula for finding the distance between the 2 points. So distance between the 2 points, and then we'll discuss the section formula for internal division. Here the distance between A and B, so we write it in short, distance AB is equals to root of the x2 minus x1 bracket square plus y2 minus y1 bracket square. Here you can use x1 minus x2 also, because there is a bracket square, and as it is a bracket square, if x1 minus x2 or x2 minus x1, the square becomes positive only. That's why we can use x2 minus x1 bracket square or x1 minus x2 also. This is a distance formula for finding the distance of any 2 points when their coordinates are given. Now suppose P is any point which lies on the segment. If P is any point lies anywhere on the segment, suppose where it lies, it divides the segment internally as it is inside in the ratio m:n. If P is any point which lies inside the segment, means on the segment AB, and it divides the segment in the ratio m:n, then section formula. So section formula for internal division, then the coordinates of this point P are given as, the order is fixed mx2. If we are taking the m ratio, we have to take the x2 coordinate only. We cannot interchange the coordinates. mx2 plus nx1 upon m plus n. While finding the y coordinate, m, if we are taking m, we have to go for the y2. my2 plus ny1 upon m plus n. So we have to learn this formula number of times. We must practice it writing. We must put the values. We must assume the coordinates x1, y1, x2, y2 to avoid some mistakes. Now, section formula for internal division. Then go for the midpoint. If this ratio is 1:1, 1:1 means P divide equally. These two segments are equal, means P is the midpoint, and here is a midpoint formula. So midpoint formula, if P is a midpoint of segment AB, then midpoint formula is sum of the x coordinate divided by 2, that is y1 plus y2 upon 2 is a y coordinate. So in this way, these two formulas, section formula for internal division and midpoint formula we discuss. We'll discuss about the centroid also, but centroid is a part related to the triangle. So we'll discuss by drawing the triangle. Now what is centroid? Centroid is a point of intersection of three medians of a triangle. Suppose this is triangle ABC. The coordinate of A are x1, y1, B are x2, y2, and C are x3, y3. These are the three coordinates. These are the vertices of the three x1, y1, x2, y2, and x3, y3. These are the coordinates of the three vertices of triangle ABC. And suppose AD, BE, and CF are the medians. Now what do you mean by median? Median is a line segment joining vertex and midpoint of the opposite side is called median. So D, this E, and this F, we can say median because it joining the vertex and midpoint D of BC, E of AC, and F of AB with the respective vertices. And these three medians for any triangle are concurrent. Concurrent means passing through the same point, and that point of concurrency is called for median as a centroid. and centroid is denoted by G, and the coordinate of this centroid by section formula when the coordinates of the three vertices are known is given by x1 plus x2 plus x3 upon 3 and y1 plus y2 plus y3 upon 3. Again, the derivation is not there, but for the study purpose, I'm telling you the proof is done by using the centroid divide the median in the ratio 2:1, and by using the formula, section formula for internal division, we can derive this relation. The coordinates of centroid when the vertices are x1, y1, x2, y2, x3, y3 is x1 plus x2 plus x3 upon 3, y1 plus y2 plus y3 upon 3. So this is a section formula for internal division, midpoint formula, and the last one we studied the centroid formula. Many more concepts are there, we'll discuss it right now. So this concept is over. Let's move for the vertices of a triangle. Now there is a common question asked in the exam that the midpoints of a triangle are given. The midpoints of a triangle are given. Let's consider the midpoint as P, Q and R. So this midpoint of the triangle are given as x1, y1, this x2, y2 and this x3, y3. So coordinates of the midpoint of any triangle are given. Then there is a direct relation with the vertices of the triangle. So if the midpoints of the triangle are known, then we can find the vertices directly by using this relation. Coordinates of point are x3 and this x2. So x3 plus x2 subtract the front midpoint coordinates, that is x1. Similarly for B, we have to add the x coordinate as x3 plus x1, x3 plus x1, and we have to subtract the front midpoint coordinates, that is x2. So this is the x coordinate. Again here for C, we'll find first the x coordinate, then we'll go for the y coordinate also. Here x1 plus x2, we have to subtract x3. So this is the x coordinate. What about y? The same trick is there for y coordinate. So y coordinate, again for this, we'll add the 2 points y3 and y2. So y3 plus y2 minus front one, y1. Again, here we'll find the y coordinate of this point B by using the midpoints. So again, here y1 and y3. So y1 plus y3 minus y2. Again here for the C coordinate, we'll add this y1 plus y2, subtract the third coordinate y3. In this way, we can find the vertices of a triangle when the coordinates of the midpoint of the triangle are given. Same trick is there for finding the fourth vertex of a parallelogram, which is our next point. Parallelogram, you all are well known. The opposite sides are parallel and equal. The quadrilateral is called as a parallelogram. So if the three vertex of a parallelogram are given, suppose this is a parallelogram A, B, C, D, and we are given coordinates of A as x1, y1, B as x2, y2, and the coordinates of C are x3, y3, and it is asked to find the fourth vertex, that is D. So fourth vertex can be found by the same as per the previous trick for triangle. So we'll add x1 and x3. x1 plus x3 will subtract the front one, that is x2. For y coordinate, we'll add y1 plus y3. Again we'll subtract the front coordinate, that is minus y2, and directly we get the fourth vertex of the parallelogram. So this is very easy to remember because both the time we are using the same trick to find the missing vertex. Now discuss the last topic, that is relation between the coordinates of a parallelogram, rhombus, rectangle and square. Let's first draw the diagram with the differences. That parallelogram, just now we discussed, this one is a parallelogram. Opposite sides are parallel and equal. This is parallelogram. Then rhombus. So let's discuss the rhombus. I am drawing this diagram for the further common questions asked in exam. So rhombus. Then we'll go for the rectangle. So rectangle. Then it is a square. So in the reverse direction we draw these diagrams. This is square. You can see all sides are equal. Each angle 90 degree is a square. Each angle 90 degree. Opposite sides are equal. In rhombus, all the sides are equal, but each angle is not a 90 degree. Parallelogram, opposite sides are parallel and equal. So if in a rectangle the measure of each angle, any one angle of a parallelogram is 90 degree, then it becomes rectangle. If any one angle of a rhombus is 90 degree, then it becomes square. There are the relationship between these quadrilateral and the types. Now what is the relation that we have to discuss? If the vertices are like this, x1, y1, in order it is very important, x2, y2, and this x3, y3, and this x4, y4. So these are only the coordinates of parallelogram. Similar way here, x1, y1, x2, y2, x3, y3, x4, y4. Same way for rectangle and square. For any of these, if the vertices are taken in order x1, y1, x2, y2, x3, y3, x4, y4, then the relation between this x1 plus x3, that is odd coordinates of x, is equal to even coordinate, sum of the even coordinate. This is the first relation. And second one, y1 plus y3 equals to y2 plus y4. This is very important concept. Again, when there are the coordinates are known, by making use of this coordinate we can solve many MCQs in a short time. So this was a very important one. One more thing related to the distance formula. There are few questions that show that it is a rectangle. So at that time we just have to find the distance. Then we have to prove that the opposite sides are equal. Then by using Pythagoras theorem we have to prove this is a 90 degree. Then only it is a vertices of a rectangle. For square, again we have to show that the length of all sides are equal and the diagonal is a hypotenuse. By using distance formula and Pythagoras theorem we can prove this one. So these tricks are used by using the geometrical property and making use of the distance formula. There is a question for 3 marks. In the second part, we'll discuss the detailed, most likely questions related to the coordinate geometry chapter. That's all from my side. Thank you, students.